Hello everyone, this is day 6, question 1 of our Leetcode activity. Move zeros. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. Note that you must do this in place without making any copy of the array. So this last line is very important, as without, if this line was not given to us, we can simply do is create a array answer and just iterate through nums one by one. If you encounter a zero, simply increase count zero. If you encounter a non-zero, push back in answers. Zero, increase count zero. Non-zero, push back in answers. Non-zero, push back in answers. So you will get count 0 is 2, 1, 3, 12. And now you know count 0 is 2, then just push back two zeros to answer, and you will have your answer array, which is all zeros arranged at the end of the array while maintaining the relative order of nums of non-zero elements. But we must do this in place. For that, we'll use a method. For that, we'll use this approach. So, you declare a variable j and set it to 0. So, right now, it's pointing towards the first element. Then, you iterate the whole array using a for loop, and this is the I pointer. This is the j pointer. Now, if nums I not equal to 0, right now, is nums I not equal to 0? No, it is equal to 0. So this whole if statement is skipped and we go to the next iteration of for loop. So we increment I. Now, yes, this nums I is not equal to 0 as it is 1. So we swap nums I, nums j and increment j. So this was nums I, this is nums j. So 1 becomes 0, 0 becomes 1, and we simply increment j and increment I as we go to the next iteration of for loop. So now this is again 0, so we skip to next. This is non-zero, so we'll swap it with the j. So this will become 3 and this will become 0. Increment j, then increment I, again non-zero, so we will make it 0 and make j 12 and increment j. Now this ith pointer has reached the last index, and this is where our for loop ends. But you can see that we have got our answer array where we have arranged all our zeros at the end of the array while maintaining the relative order. So if you think about it logically, what this j pointer does is that it always points towards the index where the non-zero number should go. And ith pointer, this I, is looking for that non-zero number which we have to insert in this jth pointer. So this will always, j will always point towards the index where the non-zero number should go, and I will iterate through the array looking for that non-zero number which will get inserted in the jth place, and just we simply increment j to the next index, and again I finds the non-zero number until and unless we hit the last element of the array where we stop, and it will be guaranteed always that all the zeros will be arranged at the last while preserving the relative order of non-zero numbers. And in the code part, it's fairly simple. It's the exact logic, which is we just declare our j equal to 0. For int I equal to 0, I less than num size I plus plus. That is, we are iterating the whole array. If nums I is not equal to 0, swap I j plus plus. That is, j is always pointing towards the index where the non-zero should go. So we only care about non-zero. So, and if we find that non-zero, swap it with j and just simply increment j to the next index. This was the approach and code implementation for Mu zeros. Thank you.